सन 1903 हवाई जहाज के इन्वेंशन ने बदल दिया दुनिया के आने जाने का तरीका। 2022 वेदांतु लॉन्चेस AI लाइव और ये बदलने वाला है दुनिया के सीखने का तरीका। इंटरैक्टिव क्लासेस, टॉप टीचर्स, सिर्फ 5,000 रुपए सालाना।
Oh hey guys, hey my Italian army, a very warm welcome to your today's chemistry session. I hope that each one of you is doing fantastically fine, and this class is going to be super important. Stay till the very end and you are going to score like 3 marks at least in your pocket. Okay, you're going to take that away from the session. So this is all about evaporation, the factors affecting evaporation and vaporization. So make sure that you stay till the very end in the session and you hit the like button of the video, subscribe to the channel so that you do not miss on any of the amazing sessions of 9th and 10th English channel Vedantu. Okay, so now starting with me, I am your chemistry master teacher Shilpi, and I guess now you guys have started taking Prodigy. The Prodigy on the 9th and 10th English channel, the chemistry part is taken by Shilpi ma'am. So be regular in the sessions, okay? And guys, one more thing. Right now the prices of Vedantu's the AI live batches, rather I would say the Vedantu Pro batches have been started now. Okay, the Pro batch is now started now, and even less than 5,000 rupees per year. Yes. Now the thing is that there is a code on your screen, SKA Pro, that should be Kaushik Army Pro. If you apply the code, then you will be getting extra discount. The price comes down to 4,500 rupees for 1 year. Yes. How many subjects are covered? Physics, chemistry, biology, English, maths, and how can I forget social studies? So hurry up, book your seat fast, guys. The amazing YouTube master teachers, if you want to get into their batch, if you want to study chemistry from Shilpi ma'am, physics from Abhishek sir, biology from your amazing Amit sir, Harsh Priyam sir is taking maths, then you gotta book your ticket here. Okay, 4,500 rupees 1 year. And where am I taking the session right now? I'm taking it on Vedantu's interactive platform for all the YouTube students. Okay, so the replay link of this session will also be available in the description box. Go and watch it from there. You can still get the same feeling of the session, and that's so amazing. Now you know that what do I call my students? Cation army. So let us start with some positivity. It is never too late to be what you might have been. Okay, so better late than never. They often say that. So trust yourself, carry yourself the way you are. Okay, let's get started with 5th session. These are the topics. This will be the roadmap, what are the things we will cover in our session. Okay, so talking about recap, first of all, in the last session we talked about that how can pressure change the state of matter. Can pressure actually change the state of matter? Definitely. Okay, so we saw examples. How can we liquefy a gas? How are we using this gases in the LPG fuels, the CNGs, isn't it? All these liquefied gases that we're using. So how do we convert a gas to a liquid? We need to maintain a high pressure so that gas particles can come closer to each other, as well as we need to reduce the temperature so that gaseous particles can lose their kinetic energy and finally give us the liquid. Okay, so how can we liquefy a gas? High pressure, low temperature, and let's say sometimes when the pressure is super high, that we will be getting the gas directly to the solid state, isn't it? So this is going to happen, like we have seen carbon dioxide gas. If you are actually increasing the pressure, it will give you a solid form directly. That was nothing but dry ice. Then if you reduce the pressure on dry ice, it gives you the gaseous CO2 back again. Yes. So we saw all the factors affecting that, like how pressure can convert the state of matter. Now we will go and talk about the evaporation, its factors, what is vaporization, and finally the applications of evaporation. Okay, let's get started without wasting any time. The first thing, we know that pressure can change the state of matter. We have seen temperature can change the state of matter. There are some phenomena happening in our daily life. For example, if you look at the screen, you are washing clothes, you keep those wet clothes in open for getting dry, isn't it, for getting them dried up. You do this every day. You are putting your clothes outside in sun, and after few hours you go and get them, they are dry completely. So the point is that, where is the water of the clothes disappearing? Where is that water? Try to look for it. Okay, apart from that, you have seen this doesn't happen all of a sudden, although like it's depicted in the picture. You can see, talk about the rainwater instead of this picture. Rainwater is collected on the roads in the rainy season, and then after few days, after 2 to 3 days, rainwater is gone. So where is that water disappearing? Animals, insects are drinking that, someone is using that? No. So why is it happening? It means the state of water is changing. Yes. So when you're washing your clothes, you're letting them dry out in the sun, then that liquid water is basically converted to vapors and gone away. Likewise, the rainwater, it is disappearing because that liquid rainwater converts to vapor and disappear. So it means that change of state can happen, liquid to vapor, without you touching the temperature or pressure. You are not giving heat to water here. When clothes are getting dried up, you are not boiling the water of the clothes, isn't it? The road water, you are not even applying anything on it. So there is a possibility that state of matter can change itself without your intervention, without you supplying pressure or temperature. Yes, liquid can be converted to vapor without reaching into boiling point. That phenomena is nothing but evaporation. Okay, and how is it going to take place? What is happening to water in these examples? What exactly is happening? Let's throw a light on it. Okay, I'll just take a simple example. Let's say we are having a glass of water. Shilpi ma'am's drawing is not very good. Manage with this. So this is the glass of water. These are the various particles even shown on your screen. The particles of water are moving. In fact, you've done this. Particles of matter are always moving. Even for solids, particles are always vibrating. So at a given temperature, at a given time, I would say, or a temperature, the particles are always moving. That means they have some kinetic energy. Yes. So here I am talking about water molecules in this liquid. I am taking a glass of water. These are the water particles. So my question to you is that, do you think all the particles of water have same kinetic energy? Like there are different layers. This is one layer, another layer, third layer, and then we have next layer. Do you think that all these particles are having the same kinetic energy? No, all these particles of water are not having the same kinetic energy. Okay, this is surprising here. The particles which are present on the top surface of the water, like this is the glass of water, these are the particles on the top. The particles on the top means the particles on the surface, they are in direct contact with the atmosphere. Okay, so the particles of the surface layer, the top layer, always have high kinetic energy here. Okay, their kinetic energy is going to be high. The reason is that they are absorbing the heat from the surroundings. Also, they absorb some of the heat from the remaining particles. If you talk about bottommost layer, the particles will be having low kinetic energy there. They are not able to absorb the heat from surroundings directly. Okay, so the point is that there are particles with different amounts of kinetic energy always. So in this glass of water that you are keeping on the table right now, the top layer particles will always have the higher kinetic energy. Okay, now because the top layer particles are like, okay, we have more kinetic energy, we are the boss. Okay, so what happens over here? The particles on the top, a small fraction of particles at the surface, they always have kinetic energy higher. So if their kinetic energy is high, without, they will be moving more faster, isn't it? They will be moving very fast, and finally they will be able to break away. A point will come, they will say, okay, enough is enough. Yes, what they will say, they'll say enough is enough, we are going to break away now. Okay, so because the particles on the surface, they are having a very high kinetic energy, so they will be able to break away from the forces of attractions of the other particles. Finally, this water that is on the surface level, that will be converted to the vapor because it has absorbed the heat from the surroundings. There is sunlight. Even in the presence of sunlight, this sunlight is helping water on the surface level to stay warm. Yes or no? Particles on the surface layer are always absorbing heat energy from the sun. So they are like, yeah, we got some extra kinetic energy. So finally they will absorb that energy and break free, become a vapor. So this phenomena of change of liquid into the vapors at any temperature, rather I would say at room temperature. If you are keeping a glass of water on the table right now, it is still evaporating. Just evaporation is a very slow phenomena. We are not able to observe it very easily basically, but it's still happening. So it happens at any temperature below the boiling point. Remember this term, below the boiling point. I will talk about it after some time, but super important while defining evaporation, because only surface particles are evaporating. We also call it as the surface phenomena. Okay, so evaporation is a surface phenomena because only a few surface particles have enough kinetic energy. They can break their force of attraction and become a vapor finally. Okay guys, so we will see some of the factors that are going to affect evaporation. What are those? The first factor is the surface area. Okay, surface area impacts evaporation directly. For example, whenever you wash your clothes, then you always spread your clothes properly in the sunlight. Yes or no? जब भी आप चाहते हो to let your clothes get dried up, you always spread your clothes. So your parents always ask you that do it properly. Don't just squeeze them and just directly throw them over the rope. So you have to go and spread the clothes very rightly. Why? Because when we are spreading the cloth, that means the surface area has increased now. That means if surface area increased, more water particles are at the surface now. When the surface area is increased, more molecules of water are at the surface now. That means more water molecules will be having sufficient kinetic energy to become a vapor. So quickly, this process will increase. A lot of particles on the surface have enough kinetic energy that they can become a vapor directly. So clothes are getting up dried faster. So it's always one point that spread the clothes properly, they will dry up faster. Instead of rolling them, the low surface area, lower the rate of evaporation. So first factor, surface area is directly proportional to evaporation. If surface area is higher, evaporation is going to be more. Okay, the next we are having is temperature. Second factor is temperature. Temperature is also directly proportional to the evaporation. That means if higher the temperature, evaporation will take place more faster, much faster. That is why, on a sunny day, you must have seen on a sunny day, clothes dry faster. Clothes are going to dry fast. Why? Because sunny day means high temperature. Yes, high temperature is there, so that means more heat is falling on the surface. More particles on the surface will be able to get enough kinetic energy and become a vapor. Yes, so if temperature is high, kinetic energy of particles on the surface level, it will be like, enough particles have the higher like the required kinetic energy to become a vapor, so they will become vapor quickly. So evaporation rate is going to increase. The third and the most important factor is humidity. What is that? Humidity. Now humidity is inversely proportional to evaporation. Yeah, you'll be like, ma'am, what is humidity? Can you put some light on it? So beta, humidity kya hai? Humidity is nothing but amount of water vapors in air. Amount of water vapors in air. Okay, so let's say if today air is holding a lot of water vapors, I would say humidity is high today. Fine. And the thing is that air can only hold limited amount of water vapors. Like let's say this is air. So air is having, limited space in it. So air be like, I have limited space. I cannot hold more than, let's say, 100 water vapors. Okay, so air has a limit. It's not possible ki as many water vapors can be, going into the air. Doesn't work like that. Now, why are we talking about humidity here? Because whenever you are doing evaporation, then what is happening in evaporation? Your liquid water is converted to the vapors. यही हो रहा है evaporation में, the liquid is converting to vapor. Where are these vapors going? Vapors are going into the atmosphere. This is what happening in evaporation. Water is converted to vapor. Those vapors are going into the atmosphere. So let's say on a certain day, humidity is very high. Okay, the humidity today is very high. That means air is already holding a lot of water vapors into it. I repeat, what is humidity? Amount of water vapors in the air. And air has a limit to which how many water vapors it can carry basically. So I am just saying that whenever evaporation is happening, those water vapors are going into the atmosphere. And air be like, excuse me, I have a capacity. I cannot hold more than this much number of water vapors. So let's say on a particular day, humidity is already high. That means air is holding a lot of water vapors. So in that case, the rate of evaporation will automatically be slow. So if humidity is high, that means air has a lot of water vapors already. So evaporation will become slow. Okay, because these vapors are not getting any space in the air. They are not getting any space. Okay, they're like, okay, wait a minute. I can hold a limited number of water vapors. That is why, on a humid day, or you can say on a cloudy day, clothes are going to take a lot of time to get dried up as compared to on a sunny day. Because on a sunny day, the temperature is high, kinetic energy of particles is high, the rate of drying of clothes could be fast. On a cloudy day, humidity is going to be high. You can see these tiny dots on the screen, they are the water vapors. So high humidity means lot of water vapors are already there. Yes, so the rate of drying will be like slow down. Okay, remember, easy peasy lemon squeezy. Fine. Very good. The last is the wind speed. The fourth factor that impacts evaporation is the speed of the wind. Okay, now what is that? How that impacts directly? Higher the wind of the speed, quicker your clothes are going to get dried up. Why? Because the wind is blowing, and the blowing wind will take away water vapors from it. Air is having water vapors, and wind will come and say, okay, I will take away all the water vapors. So that means surrounding air will be having now lots of space to hold more water vapors. So it was just like, let's say air was having lot of water vapors. Now wind is blowing. Wind will take away all the water vapors and the space becomes empty. Okay, there's a plenty of room now for the water vapors again. So these are the four factors. The first is surface area. the second is temperature, the third is humidity, and the fourth is wind speed. Remember that. Okay, now I am giving you a homework question. What is that? Will be asked in your exam also. Very important, we will discuss this. The difference between vaporization versus evaporation. Vaporization, also known as boiling. What is the difference? This is your homework. Okay, I'll give you 1 point of difference here. Whenever you are doing boiling, then what is happening? Boiling you are doing by giving the heat energy from outside. When you are boiling water, you are giving heat to the water. But evaporation it is happening at the room temperature. Evaporation is a surface phenomena. What do I call beta? Evaporation as surface phenomena. Why? Because only the surface particles have enough kinetic energy that they can break their force and finally become a vapor. Okay, so only surface particles have enough kinetic energy. But when I talk about boiling it happens at a fixed temperature. Water will be boiled only at a fixed temperature, like 100 degrees Celsius at 1 atmosphere pressure. So what happens? I am giving heat energy from outside. So in that case, every water molecule will be having the same kinetic energy, because you are giving heat from the outside. So when we boil water, every particle has equal chance of becoming a vapor. So we can say boiling is a bulk phenomena. What do we call boiling as? Bulk phenomena. Okay, like the bulk of the molecules, the bulk of the liquid molecules have enough kinetic energy that they can become a vapor finally. Okay, so you would have never seen, no matter how high the temperature is, water cannot boil itself. Water never boils below its boiling point. But evaporation happens below boiling point, because at boiling point all the particles will be having the same kinetic energy. It will become a bulk phenomena. Fine. So vaporization is nothing but the boiling only, where the change of liquid into vapors happens at a fixed temperature at a given pressure. Okay, so write this difference. This is asked in the exam. Remember it. The next are the applications of evaporation. So now evaporation can cause cooling. A very a common example I will say. Let's say you are using your hand sanitizer. You have used hand sanitizer, you rub it, and then you feel thanda cool. That hand sanitizer has alcohol in it. What alcohol? It's only ethanol in water. Hand sanitizer it's like 78%, 80% depending on sanitizer. You are having ethanol mixed with the water. Okay, and whenever you pour this ethanol on the hand, when you keep it, it is a very volatile liquid. Volatile means easily converted to vapors, and you will feel very thanda cool. The same with acetone or the nail polish remover, that also feels cool. The same happens with perfume also. Okay, so why does it happen? Because all these are the volatile liquids. They are all volatile liquid. Volatile means easily converted to vapors. What is that? Easily converted to vapors. So let us say this is the perfume, okay, or hand sanitizer. I keep it over my palm. यहाँ पे भी रख सकते हो, कहीं पे भी you keep it. When I keep it over my hand or skin, what happens? This is a liquid. So this alcohol absorbs the heat energy from the body. Your body is also having higher temperature. The moment you keep a drop of perfume on your hand, that perfume is liquid. That liquid absorbs the heat energy from the hand. From where it is absorbing the heat? From my hand, from my body, and it will use that heat energy to convert itself into vapor, because it is highly volatile. They need very less amount of energy and they can become a vapor. Okay, so whenever you are putting that acetone liquid on your hand, this liquid absorbs the heat energy from your body and becomes a vapor. Okay, because your body has given some heat content. Your body has lost skin, has lost some heat content. So if your body loses some heat content, how will you feel? Thanda thanda, cool cool. Okay, so when you rub it, it becomes vapor by absorbing heat from your hand. So your hand would be like, wow, I like it. That is losing its heat energy, so feels quite cool. Okay, so evaporation always causes cooling. Remember that. For example, earthen pot, जिसको हिंदी में we call it मटका. The water kept inside the earthen pot is always cooler as compared to water जो normally रखा होगा at room temperature. Why is it so? Because earthen pot is having some pores into it. There are tiny pores in the earthen pot. Okay, and via those pores, water can penetrate out. The water that is kept inside, देखो फिर से सुनो. This is the water that is kept inside the pot. Okay, and this pore, what do we call, earthen pot is having some tiny pores into it. Via these pores, some of the water droplets can come outside. They can penetrate out, we can say, not all of the water, because these are very tiny pores. Some of the water droplets will come outside. Now these water droplets will absorb the heat energy from the water kept inside the earthen pot. So this water will absorb the heat from the water kept inside the earthen pot, and these water droplets will use this heat energy from the earthen pot and evaporate. Because the water kept inside the pot has given out some heat energy, isn't it? You can see water kept inside the pot has given its heat energy. Okay, it has given its heat so that these water droplets can evaporate. That is why this, because earthen pot has lost some heat content, the water inside the pot, sorry, has lost some heat content, so you will see that it will be cooler. Again, I'm repeating if you have like any confusion. So I was saying that the water kept inside it can, some of the drops can penetrate out on the surface because there are tiny pores. Okay, when they penetrate out on the surface, these droplets absorb the heat energy from the matka water only. Okay, these tiny droplets will absorb heat energy from the water kept inside the matka, use that heat and evaporate. Because this water inside the matka has given out its heat, so it will become thanda thanda, cool cool. Okay, so evaporation causes cooling. For the same reason, you should always prefer to wear cotton clothes in summer. Why? Why should we wear cotton clothes in summer, beta? Because cotton is a good absorber of water. Okay, cotton is a good absorber of the water. So ma'am was like, ma'am, boss. Yeah, good absorber of water. So it will be absorbing the sweat as well. So this cotton is going to absorb the sweat from your body. It will expose it to evaporation now. Okay, and the evaporation happens by taking the heat from your body. Okay, so your body temperature would be becoming, cool. You're like, I like it. For the same reason, sweating is a body's natural cooling system. Why? Because when the sweat evaporates from the body, this is your sweat, this is the sweat gland, you can see. Okay, so whenever sweat evaporates from the skin, it always takes away heat from the body. This is the sweat will absorb heat from my body and then evaporate. So because my body has lost some heat content, it becomes thanda thanda, cool cool. Okay, so these are some of the examples. Apart from this, people, you have seen on the roof, they sprinkle water in the summer season. Why people sprinkle water on the roof? Because that water also absorbs heat from the hot surface, isn't it? There is hot roof, and if you sprinkle water on a hot roof, the water molecules will absorb heat from the roof surface and evaporate. Because the roof surface has lost some heat energy, so you would be feeling like, thanda thanda, cool cool. Okay, so roof pe sprinkle water during the summer, people. That is again the impact of it. You would have seen if someone is having high fever, what people do, they try to keep you can say wet cloth on the forehead or on the body, the palms and hands. Why? If a person has very high temperature, if you keep a wet towel on their forehead, then the water molecules in the cloth will absorb the heat from the body and evaporate, because the person body has lost some heat, so fever starts coming down. That is again evaporation causing cooling. Okay, these are some of the applications, and if you want to do complete the chapter along with your completion of the syllabus with unlimited live in class doubt solving, with lots of quizzes in the class, assignments, notes, and the regular test series for entire 1 year, you can come with us in Vedantu's Pro Lite subscription. Not talking about Classic and Plus Beta, because the rate is very high there. So still you are having time. The prices of this course are going to increase. Right now it is at 5,000 rupees for 1 year. If you apply Shilpi ma'am's code SKA Pro, it will become 4,500. Okay, so do check the link given in description box of this video. I'm going to show you. Yes, hair only. Wait a minute. The video that you are watching, like any Shilpi ma'am's video, you can open. Let's say I am opening this video, or the video that you're watching right now. Okay, the video that you're watching right now, you have to like the video, scroll down, and in the description box you will see Vedantu Pro classes. Okay, over here. Avail all exciting Vedantu courses by clicking over here. So if you tap here, sorry, so if you scroll down and down, it's all the details are written. These many subjects you would be getting, the access for all these subjects. 1 year plan, the YouTube master teachers you will be getting there. Go with simply class 9 CBSE Vedantu Pro Lite, 1 year 4,500 rupees, unlimited doubt solving during the live class, unlimited replays, the session notes available, assignments and notes, study material would be given to you. The regular test series would be conducted. Okay, the code is already applied. आपको simply tap करना है buy now पर. Remember, ma'am's code is SKA Pro. Shilpi Kaushik Army Pro. 4,500. Any of these methods of payment you can do, and it is like super duper worth it, affordable. There is no second thought about it. Okay, guys, so go for it directly. Don't think, because the prices are going to increase around like a lot. Prices will be increasing, so abhi aapke paas time hai. Okay, grab it ASAP. One or two days you will get it for 4,500 rupees 1 year. Next week bhi kya 2-3 din baad prices will increase, then it hurts a lot. Okay, talk to your parents. Each and every penny is worth it, and you will make your 9th class a bang performance. This is the homework question. I've given you 2 homework questions to be answered in comment section. This and evaporation versus boiling. Okay, hints I have given you already. Make sure you subscribe to the channel. This is Shilpi ma'am's Instagram. You can follow me on the ID I am Kitayan. You can join our Telegram channels, link in the description box. I would like to thank all my Kitayans for attending the session and being so regular in the classes. You all deserve this. Okay, amazing guys. I'll see you next time. Take care, see ya, and make sure that you hit the like button of the video and subscribe to the channel. Okay, see ya.